Hello everyone, today we're going to be going over question 10 from paper 2 of the sample assessment material for Edexcel for the Pure Maths IGCSE. So this is going to be the longest question I've ever done, and it's 18 marks long, and it is a question both about calculus and about Cartesian coordinates. So yes, I think the rectangular Cartesian coordinates falls under topic. Perhaps it is 8. Yep, topic 8, and calculus would be topic 9. Alright, so figure 1 shows the curve M with the equation y is x cubed minus 13x minus 12. The point P with x coordinate negative 2 lies on M, and line L1 is tangent to M at the point P. So first we need to find an equation for L1. So we find the y value, which would be f of negative 2, and then we find the gradient, which would be dy dx for x is equal to negative 2. Secondly, the point Q lies on M, and the line L2 is tangent to M at the point Q. So we need to find an equation for L2. So in this, we'll need to find the coordinates of the point Q, because we want one point it passes through. And we will need to find the other point on M, which has the same gradient, because I can see already, since this is a cubic equation, the differential will be a quadratic, and it'll have 2 points where the gradient is the same. So given that L1 and L2 have the same gradient, we need to find the other solution for this M is equal to dy over dx for which value of x, and then using that we can find f of that x to get the y value for point Q. And once we know this point Q and the gradient from the last question, we will be able to find an equation for L2. Thirdly, the normal to M meets at P, which is the first point, so the normal being the line that goes perpendicular to the curve, meets L2 at the point R. So first and it says find the coordinates of R. So first we need to find the equation of the line L2. We know it already goes through the point -2 and f -2, and we know it'll have gradient 1 over or -1 over whatever dy dx for x is negative 2, because it's the normal and it's perpendicular to the tangent. And it says find the coordinates of R. So we need to make this normal line, so let's call it n1 since it's normal from the first point. This normal line intersects with L2, and then find the exact length of line PR. So we know the coordinates of P before, it's -2, f -2, then R is the intersection between N1 and L2, and we can calculate the rise and the run, and we'll use the Pythagoras theorem to find the distance there. So it should not be too hard. And then finally, the tangent and normal at P and the tangent and normal at Q form a rectangle. So the tangent and normal, or tangent and normal at these 2 points would form something like this. And although one might think at first glance to get all 4 points to figure out the sides of the rectangle, we just need 3 of the points, and they tell us to find 3 of the points because we'll know point P, point Q, and point R. So what is likely to happen is that this point P and Q and R, or whatever, I think this is R and this is Q, either way, point P, Q, and R will make a short side and a long side of a rectangle, and since the area of a rectangle is BH, we'll know BH already, and we don't need to know these 2 sides or this point to figure out the area of the rectangle. So that's where we'll go with that. That's how we will approach this question. Alright, so firstly, the point P with x-coordinate -2 lies on M and line L1 is tangent to M at the point P. Find an equation for L1. Alright, so first, the y-coordinate of P is equal to f of -2. So that would be equal to -2 cubed minus 13 times -2, and finally minus 12. So this is equal to -8 plus 26 minus 13 times minus 2, positive 26, then minus 12, which is equal to 26 minus 20, or positive 6. So the coordinates of P are -2 and 6. Next, we want to find the differential at this point. So the gradient of L1 would be equal to the differential of fx, so dy by dx, for x is -2. So that would be equal to, you have the equation x cubed minus 13x minus 12, and so first you differentiate x cubed to get 3x squared, and then minus 13x to get minus 13, and then minus 12 is a constant term, so it has the differential of 0, and so you have this for x is -2, which is equal to 3 times -2 squared minus 13, which is equal to 12 minus 13, which is equal to -1. So the gradient of L1 is -1. And finally, if we want to get this equation, say in the form y is mx plus c, we will have the y6 is equal to mx, so minus 2, because m is -1, so 6 is equal to minus 2, so -1 times -2, plus c, or 6 is 2 plus c, or c is 4. And therefore, the line L1 is the equation y is minus x plus 4. Now, secondly, we want to find the other point, the other x-coordinate for which the gradient is also -1. So, B, where else is the gradient equal to -1? That's the question we have to answer, and so we make our expression for the differential, 3x squared minus 13, be equal to -1, and we get 3x squared minus 12 is equal to 0. And I'm seeing that we can divide every term by 3 and still have whole number coefficients, so we're going to divide by 3 and get that x squared minus 4 is equal to 0, and I'm instantly seeing that this is a difference of two squares that can be factorized into x plus 2 times x minus 2 is 0. And therefore, x can be 2 or minus 2, positive 2 or minus 2, for dy over dx to be equal to -1. So the other x-coordinate is positive 2. Now we want to find an equation for L2, and so the y for the point Q is equivalent to f of positive 2, which is equal to 2 cubed minus 13 times 2 minus 12. And this is equivalent to 8 minus 26 minus 12, or 8 minus 38, which would be equal to negative 30. And so we find that the y value for Q is negative 30. So therefore, Q is the point of positive 2 and minus 30. And now we know that this line with the gradient m is equal to negative 1 passes through this point 2 and minus 30, and therefore minus 30, which is the y, would be equal to minus 1, which is the gradient, times 2, which is our x, plus a constant c. So minus 30 is equal to minus 2 plus c, or minus 28 is equal to c. And therefore, the equation of the line L2 would be equal to y is equal to minus x minus 28. And that will work because it will pass through our point 2, negative 30, and it is also parallel to the equation we determined earlier of minus x plus 4, which we found here. Now, that is a very easy 9 marks for this question already. And next we will need to find the coordinates of the intersections of the normal to M and the point R, so and L2. So first we need to find the coordinates of R. What I'm going to do first is find the equation of the normal to M. So we know that the gradient of the normal would be equal to negative 1 over the gradient of L1, which would be equal to minus 1 over minus 1, which is just positive 1. And we know that such a point, if it were the normal from the point we determined earlier, the normal of point P, it has to pass through the point minus 2 and positive 6. So if we say that y is equal to minus 2 plus c, because the gradient is 1, it does not show up when we evaluate the equation. 6 is minus 2 plus c, and so 8 is c, and the equation of the normal to M is equivalent to y is equal to x plus 8. And therefore, to find the intersection of the first normal line and the other line, L2, we have to make y is equal to x plus 8 equal to y is equal to x minus 28. And so we get to the point that x plus 8 is minus x minus 28. Add x to both sides, 2x plus 8 is equal to minus 28. Then subtract 8 from both sides, 2x is equivalent to minus 36. And therefore x is minus 18. So if x is minus 18, and y is x plus 8, I'm using that equation because it would be simpler to calculate. If x is minus 18 and y is x plus 8, that means y is minus 18 plus 8, or negative 10. And so the coordinates of R are minus 18 and minus 10. Because the x value is minus 18, which we got from solving this equation is equal to this equation, and the y value minus 10 is what we got from substituting our value of x into this equation. So we found the coordinates of R, and we're already 13 marks into the question. Now, frankly, I'm quite surprised that I got this far so quickly, because many other extremely long questions beforehand have taken upwards of half an hour, but this is not even 15 minutes into the recording. And so I will speed ahead with the next two parts of the question. we need to find the exact length of the line PR. So to refresh our knowledge, P is the point -2 and 6, and R is the point -18 and -10. If we use the Pythagorean theorem, we know that the square of the distance PR is equal to, firstly, I'm going to use P as the one we're subtracting from because its values are larger. It is -2 minus -18 squared plus 6 minus -10 squared. And this is the change in x value, and this is the change in y value, and the sum of the squares of these will give us the square of the distance PR. So again, PR squared is -2 minus -18, which would be 16 squared because it's -2 plus +18, so 16 squared, and then plus 6 minus -10. And since we have +6 minus -10, that's 6 plus 10, which is also 16. So it would be 16 squared plus 16 squared. And since PR squared is equal to what we know as 512, because it's 256 plus 256, we can take the root of that. PR is root 512, which would be 16 root 2. And you can also have the insight that this goes directly to the value of 16 root 2, because this is 16 squared plus 16 squared, which is, if you factorize the 16 squared out, it would be 16 squared 1 plus 1, or 16 squared times 2. And if you take the square root of both of those, you just get 16 and then the root of 2. So that's a piece of intuition that you could have spotted, but I've done this to make it clear what I'm doing. So the distance PR is 16 times root 2. And finally, it's telling us to find the exact area of the rectangle that the tangent and normal at P and the tangent and normal at Q form. So if we kind of sketch what we found that the line for x is -2 has a gradient of -1, so it might be about here. And we know it's positive as well, because the y-coordinate is +6. And so that's a really awful gradient of -1, but I'll try better on this one. It'll be somewhere around there. Oh my god, that's even more terrible. This should be touching. And this is not even at the correct point, but whatever. But just generally, we found these 2 points here, P and Q, and the normal to the P also intersects this line at R, and this would be our normal N1, and this would be our first tangent L1 and our second tangent L2. We found that this distance is 16 root 2, and we know it's going to be a rectangle because these are all perpendicular. And so once we know this side, we just need to know RQ, and since we know the coordinates of R and Q, we can work that out pretty easily. So once again, we refresh our memory with the fact that Q is +2 and -30. So Q is 2, -30, and on top of this, we are taking the distance to it from the point R, which is the intersection of those two lines earlier. So we have R is -18, -10. So finding the distance to this is exactly the same process as before, but I'll go through it again anyway. So once again, the square of the distance, QR squared, would be equal to, and let's say R goes first this time, so -18 minus positive 2 squared, and add to that minus 10 minus 30 squared. And you may find that this is equal to minus 20 squared, or rather this is minus 30 squared. So let me just rewrite this more clearly. So negative 10 minus negative 30, which would be equal to negative 10 minus negative 30. There should be two minus signs there. And this is, the first one has only one minus sign because it is a positive 2 here. And you'll get minus 18 minus 2 is equivalent to minus 20, so it's minus 20 squared plus, and then minus 10 minus minus 30 is minus 10 plus 30 is 20, positive 20, so minus 20 squared plus positive 20 squared. And of course, these two expressions are equivalent to each other, and you could do this little factoring trick that I got earlier, because you'll get that it is equivalent to 20 squared times 2, and you take square root of the whole thing, you'll get 20 times root 2. But of course, I will evaluate this in another proper way if you would like me to. So QR squared is minus 20 squared plus 20 squared, and then QR squared would be equivalent to 400 plus 400, which is equal to 800. And then QR is therefore the root of 800, which is 20 times root 2. So once we know this distance, we can find that the area is equivalent to base times height, which is equivalent to the distance PR times the distance QR. And this is equivalent to the distance PR, which is 16 root 2 times the distance QR, which is 20 root 2, or 16 times 20 times root 2 times root 2, and of course this becomes just 2, and this becomes 320, or 320 times 2, which is 640. So ultimately the area of this is 640. Alright, so to reflect on this question, I think it was much more simple than its intimidating structure gave it out to be. And if you ever are overwhelmed by a question with many parts, do not be overwhelmed, because it is often that these kinds of questions will be fairly forgiving and simple and straightforward for you to undertake. So I'm just going to have a drink of water. Alright, I'm done drinking my water, and then I'm going to go down to the mark scheme and see if we were correct. So our final figure for the area of the rectangle, of course, was 640, and the distance QR was 20 root 2, distance PR was 16 root 2, the coordinates of R were minus 18 and minus 10, coordinates of the line of L2 was y is minus x minus 28, and the line L1 is y is minus x plus 4. Alright, so let's go down to the mark scheme. And word of warning, I know that they give the answer to the equation of L1 in a different form, namely the form of ax plus by plus c is equal to 0. This is simply an alternative form of giving the line of a linear equation. Like, there is some things you can do with this that you can't do with the y is mx plus c at a glance, but I might talk about this in a future video. Alright, so so we found the y was f of negative 2, and we found the gradient to be negative 1, so the equation of the tangent must have been y plus x minus 4 is 0, and we got y is equal to minus x plus 4, or y is equal to, or y plus x is equal to 4, or y plus x minus 4 is 0. So this is the same as this. So yep, that would be an OR equivalent there. they will not mark you down for putting a linear equation in the wrong form. If they do, that's just unfair, and they will know what they're doing. Examiners who mark this are often enthusiastic about this, and they will know what you're trying to say if you happen to put your answer in a different format. The only exception to this, I would say, is leaving fractions irrational. If you had like 1 over root 2, you might get marked down for that if you didn't put, say, root 2 over 2, for example. But apart from that key edge case situation, the examiners won't mind what form you put your answer in. And also, make sure you simplify your fractions and surds. That doesn't count as the same form, but I suppose in lines and the equations of lines, it's okay. So we find that the gradient is equal to that, and we solve it for the other values of x. So at q, x is 2, f2 is minus 30, and therefore q is 2 and minus 30. So yeah, we got both of those points. And then y minus minus 30 is minus x minus 2. Well, I suppose that's quite the strange way of doing it, but we just substituted our values of x, y, and m in there. But we did come up with the same line of y is minus x minus 28, right? And then the gradient of the normal is 1 because it's minus 1 over minus 1. And the equation of the normal is y is x plus 8. We found that out correctly as well. And at r, x plus 8 is x minus 28, so x is minus 18. And then we solve this value here to get the y value. The y value is minus 10 because we substituted minus 18 into the equation of the normal line here. And this mark scheme goes over multiple pages actually. So this is the coordinates of r is this, and so PR is this distance. And then the area of the rectangle, the length of QR is this, which is 20 root 2. Yep, so we got both of these distances correct, and then the area is this times this is 640, correct. And now I just want to have a note about this alternative method. It is quite the ridiculous way to go about finding the area of a rectangle, because I'm fairly certain it has something to do with matrices and determinants of matrices, and of course this is a complicated subject which you basically won't touch until much further in your math studies, but it is a way of doing this. I think they might learn this in America or something, but you can safely ignore this part of the mark scheme. It is simply a more complicated and less straightforward way of getting the same answer. Furthermore, in this method, you must calculate the fourth vertex of the rectangle, which is kind of unnecessary. Alright, so yep, we got these marks and we got the correct answers for all of these, and so it is the satisfying result of 18 out of 18 marks. Alright, thank you for watching.